Hi ladies and gentlemen, this is Mr. Green again, and I'm here to do another video on Algebra 2, and we're going to be taking up a new concept, one that you haven't seen in a while before. It's called a piecewise function. Now, what the objectives are is for us to be able to identify piecewise functions, to be able to determine whether the relations represented in various forms are functions, determine whether the domain and range of the function is, use function notation to evaluate the functions for a given value, and draw a graph of a function and or determine its domain and range. So what I'm going to talk to you about is a piecewise function is any function in which the function doesn't have the same expression all the time. So, as you can see from the one that's given up here on the screen, you notice that for x less than 1, we're using 2x. But if x is equal to 1, we're using the value 1. And when the x is greater than 1, we're using the value x plus 3. This is what's known as a piecewise function. I'm defining it differently over different domains, okay? Now, anytime the domains overlap, it quits being a function, because then I would have two values for the same location. So a piecewise function, you have to be very careful that it doesn't overlap. I want you to notice right here, we're saying less than 1, and we're saying equal to 1, and we're saying greater than 1. This one does not overlap. I have three separate functions here that do not overlap, even though the same value is used for all three of them here. And we need to evaluate this portion of the function at this value to see what's going on. There is no overlap between those, because at 1, it's not this first one, it's the second one. And it's not the third one, it's the second one. And that's what you have to look at, is to make certain you don't have less than or equal to and an equal to at the same location, because those would get you a non-piecewise function. It would not be a function that way. Okay? So let's look at a couple of them here. We're going to take this first one. We're going to go back to our trusty t-charts, where we're putting the x in one place, and we're going to find g of x in this situation over here. So negative 2. Negative 2 is definitely less than 1. So negative 2, I'm going to be using this 2x function right here. Right? So negative 2 times 2 is a negative 4. Guess what? Our point's going to be located at negative 2, negative 4. So let's just go ahead and plot that. Negative 2, negative 4. 2, 3, 4. Right there. So I'm going to do negative 1. Negative 1 times 2 is negative 2, is equal to negative 2. 0 times 2 is 0. 1 times 2 is 2. Wait a second, Mr. Green. It's not defined at 1. But see how it's less than 1? I need to know what it's doing right here, because what I'm going to do at this point is I need to make that an open circle. So at 1, 2, right here, there needs to be an open circle right there, because I'm never going to hit that point, am I? So let's go to negative 1, negative 2, and at 0, 0. So that's what we're seeing for that first function, is it's going up like that. Let's go ahead and draw that function in. Will it hurt us any? Not at all. I'm going to start right here and draw up to here, but see how it's got that open circle? It's not going to include that point. That means it gets absolutely close to that point, but not quite that point. So at 1, what is the value? Well, it's 1. So it's going to be right there. That's where the solid point would go, is right there. Now, how about if it's greater than 1? So at 1, it's going to be 1 plus 3. That's going to be a 4. And at 2, that's going to be 2 plus 3. That's a 5. And at 3, it's going to be 3 plus 3. That's a 6. And at 4 plus 3, that's a 7. Okay, well, let's go. Over 1 up to 4. 1, 2, 3, 4. Up to, well, it has to be a circle, doesn't it? Because I've already got a point at that location. Sorry, had to cough. So I've already got a point at that location, and it's not defined. It has to be greater than 1. But I wanted to see where to put that open circle. So I had to put that open circle right here at 4. So at 2, it's going to be at 5, right there. At 3, it's going to be at 6. right there. 4 is going to be at 7. So I can draw a line that's going to include all of those. It goes right up to that point, but doesn't include that point. That's what my piecewise function looks like in this particular situation. Okay? So let's look at another one here. We're saying f of x is equal to x plus 5 if x is less than negative 2, and it's equal to negative 2x minus 1 if x is greater than or equal to negative 2. See how there's no overlap between these numbers? Okay? X less than negative 2, x greater than or equal to negative 2. There's no overlap there. Okay? I will need to evaluate this first function at negative 2. Okay? So I want to make certain I find f of negative 2. But I also want to find some other values that I can use there. So I want to go f of negative 3 and f of negative 4. Why am I picking negative 3 and negative 4? Because it has to be less than negative 2. That's why I picked those numbers less than negative 2. And I'm adding 5 onto it. So what am I going to get here? I'm going to get a 3, 4, and a 5. Right? No, wait a second. 3, a 2. I can't even add in my head. And a 1. You can tell I've got a head cold. 3, 2, and a 1. Okay? So let's look at it when x is greater than negative 2. Well, what's greater than negative 2? Well, let's start with f of negative 2. Move that back out of the way. Thank you. F of negative 2. Out of the way, please. Thank you, little drawing tool. So now let's look at some more numbers. So let's see here. F of negative 1. F of 0. I always like doing 0. F of 1. Okay? So let's evaluate those. It's negative 2 times x. So negative 2 times negative 2 is a positive 4, minus 1 is a positive 3. Negative 1 times negative 2 is negative 2, minus 1 is a negative 1. 0 times negative 2 gives me a 0, minus 1 is a negative 1. Oops, that doesn't look quite right. Negative 1 would be a 2, minus 1, it'd be a positive 1. Golly, Mr. Green, making a mistake already. 1 times negative 2 gives me a negative 2, minus 1 would be a negative 3. Okay, so let's go through and try and plot some of these points out here, okay? So at negative 2, 1, 2, we were at 3. 1, 2, 3. Where did I get that point from? That's this one right here. Negative 2, 3. This one is going to be negative 3, comma 2. This one's going to be negative 4, comma 1. Okay? So negative 3, comma 2 is right there. Negative 4, comma 1 is right there. But remember, at negative 2, do I have a solid point? No. I've got an open circle. I've got to make certain I remember that, or else it will be wrong. Okay? So let's see here. What do we got? We got a line that looks something like that. Okay? So down here at these points, get my pen back. Where am I plotting this one? I'm plotting this one at negative 2, comma 3, negative 1, comma 1, at 0, comma negative 1, and at 1, comma 3. Okay? Negative 3. 1, comma negative 3 is right down here. 0, comma 1 is right, negative 1 is right here. Negative 1, 1 is right here. And at negative 2, we're at 3, is right here. Now, is this one an open circle or a solid circle? It's a solid circle. Why is it a solid point? Because I've got less than or equal to. That means at negative 2, I do get this point right here. So I can now draw this line. And this piecewise function looks like this. Oh, wait a second. I misplotted that point. Go back, Mr. Green. That was wrong. That point right there is wrong. Thank you. You guys are supposed to stop me when I'm doing that. Oh, wait a second. You're not here with me. This is a recording, right? Okay? So at this one, negative 2, 3, negative 2, 3. That's this point right here. Well, wait a second. That was a point that we just excluded in the other one. Just because they wound up at the same value doesn't mean that we don't plot them separately. Okay? So it would be like this. Like that. Okay? That's what this piecewise function would look like. And then, yes, same value, wasn't it? Because we put this value in at -2 and we got a 3, and we put in a -2 over here and we got a 3. -4 minus 1 is a negative. No, it's +4 minus 1 is a 3, yes. So we got the same value. So it is both an open circle and a closed circle. And you need to be distinct on that and make certain people understand it. Now, is it a function? Yes, it is a function because there is no overlap. Okay? What's my domain? Once again, they continue on forever and ever and ever and ever and ever. My domain is going to be -infinity to infinity and beyond. Open circle, open things there. My range in this situation is going to be, well, it's going to go from -infinity, right? And it's going to stop up there when it gets to 3. And it does have a value at 3, so I would put closed brackets on it. That would be my range. So let's look at f of 3. Well, f of 3 is in this range right here, right? How do I know that? Because 3 is greater than -2. So I'd stick a 3 in for x, and I get -2 times 3. That gives me a -6. Minus 1 is a -7. Does that make sense? Well, if I go to 3, 1, 2, 3, down to -7, 1, 2, 3, 4, 5, 6, 7. You know what? That line does look like it's going to get there eventually. What about at -4? Well, we actually figured it at -4. We got a +1 here. -4 fits into this piece of the piecewise function right here. -4 plus 5 is a +1. How about -2? Stick a -2 in here. -2 fits into this one right here. Okay? Why? Because this is the one that's got -2 equal to -2. So -2 times -2 is a +4 minus 1 is a 3. Okay? Going forward. Look at this piecewise function. So for x less than or equal to 3 and x greater than 3, I can answer real quickly, yes, this is going to be a function. There's no overlap. Okay? So x less than 3. So at f of 3, we're going to get a value of -3. At f of 2, we're going to get a value of -3. At f of 0, we're going to get a value of -3. Boy, that is a boring function. So let's see here. Starting at f of 3, go down 3, because my y value is -3. 1, 2, 3. I'm going to have a solid point right there at 3, and it's going to be a line going this way. Wow. Boring. Okay? So let's look at things that are greater than 3. At f of 3, I get -2 times 3 would be a -6 minus 1 is a -7. Okay, got a cough. Trying not to share the cold with you guys. So at f of 4, I'm going to get 4 times -2 is a -8 minus 1 is a -9. At f of 5, I'm going to get 5 times -2 is a -10 minus 1 is a -11. So that means at 3, 1, 2, 3, -5, 1, 2, 3, 4, 5. There would be an open circle right there at 5. And at 4, it's going to be at -9. And at -11, it's just going to keep going that direction, isn't it? So my line is going to look something like that. So there's my piecewise function that I just graphed. Okay? Once again, domain, pen. My domain is going to be from -infinity to infinity and beyond. Open brackets on this one. My range is going to be from negative infinity, but it's going to stop at negative 3. That's going to be a closed end bracket. That's the way you would express that. Okay? So looking at this one. So they're wanting us to come up with the equation for this one. I'm going to look at this and I'm going to start on the right hand side. So for x greater than 0, okay, that means I'm going to have an open circle right here at 0. I'm going to see that it's got a slope of over 1 up 2. It's got a slope of 2, so it's going to be 2x. And I can see that it goes through the origin, so there's nothing going to be added onto it. So that's all it's going to be is 2x. And then for x less than or equal to 0, that way I get this thing filled in as a solid line. It looks like it's got a slope of over 1 down 1, that's negative 1, so it's a negative x. So my function, piecewise function, using my little curly bracket there, would be, and move you out of the way, thank you, would be f of x equals that. Wow, equal sign's got a little spot on it. Don't know why. Okay? See how it's got that one break in it? That's how come I knew it would do that. They're wanting us to write this equation. Well, first of all, I'm going to identify the domain areas that I need to be concerned about. Okay? I can see that it goes from negative 2 to 2 right there. And so what I'm going to say is x greater than or equal to 2. I'm going to say at x less than or equal to negative 2. And then here in the middle, I'm going to say from negative 2 to less than x less than positive 2. See how I developed the range here real quickly? I first of all looked at it and said, well, this goes from negative 2 that way. This one goes from 2 to negative 2, and this one goes from 2 and that way. So I'm just developing my ranges here. So at x greater than 2, I'm looking at this line over here on the right. It looks like I'm going down 3 and over 1, so that is a 3x, right? But my x-intercept would not be until way up off my screen. So I need to figure out one of these values on it so that I can figure it out. So I'm going to say at this point right here, at point 1, 2, 3, 1. So I know it goes through the point 3, comma 1, right? So what am I looking at? I'm looking at the slope-intercept form. Y equals mx plus b. My slope is 3, so 1 is going to be equal to 3x. Well, that was a 3, so 3 times 3 plus b. That means that b must be equal to, because I'm going to get 9 here, and when I subtract 9, I'm going to get a negative 8. Oop, my slope was a negative 3, so I'm going to get a negative 9. I add the 9 to both sides, and I'm going to get a 10. So b is equal to 10. So this is going to be a negative 3x plus 10. So at this point, 4. How did I get that? Well, I just counted up 4 spaces. 1, 2, 3, 4. It's always going to be 4. When I'm in there, it's always going to be the value 4. Come on. Right there. Looking at this left side going this way now, okay? I can see that my slope is 1, 2, 3 down and over 1, so it's going to be a negative slope again. Wait a second, that's a positive slope. So it's going over 3 and up 1, so that's 3x, but I don't know the values for it. So I'm going to use this point right here. It's going through the point negative 3, comma 1. Okay, using my slope-intercept form, y is equal to 3x, right, plus b. 1 is equal to negative 3 times negative 3 plus b. That gives me a negative 9. Adding that to both sides, I get a 10. So b equals 10. So my equation is going to be a plus 3x plus 10. The only difference here is this has a negative slope. This one has a positive slope. And I would write that as my piecewise function. G of x is equal to that. Okay? So having done both of these two, look at this one. We've got a disconnect here. These are not equal. Okay? So that means that for x between negative 1 and 1, so I'm going to put little less than signs in there, and just less than signs. Okay? Y, let's see, that's going up 1 and over 1, so it's going to be a positive slope of x, and it hits the y-intercept at 1, 2, 3, so it would be x plus 3. Okay? So let's look at this line over here to the right. It's got an x-intercept right here. It's going to hit the x-intercept down there. That's going to be an x plus 1, and that's going to be for everything that x is greater than 1, and for everything x less than negative 1, it's going to be x plus 2. Yes. Okay? And that would be my function, my piecewise function. Okay? So if I pick the point 0, well, 0 is in this range right here, and I stick 0 in, 0 plus 3 is 3, so at 0 I should be at point 3. 1, 2, 3. Yes, that's what's the point that's on the graph. And that's the way I'm checking this, is by picking some points. If I pick the point 2, 2 is greater than 1, that would be this one over here. So 2 plus 1 is 3, so if I go to 2, I better be at 3. 1, 2, 3. Yes, I am. Good. So let's pick the point negative 2. Negative 2 would be in this function down here. Negative 2 plus 2 is 0. So at negative 2, I should be at 0, and I am. I've got all three functions finding points at the right spot. Okay. As I say every time, if you're sending me messages, make certain you tell me you're in Algebra 2 so that I can find your names quickly and get your answers to you really quickly. I appreciate it, guys, and I'll see you next class period.